Our perception of reality leads us to believe that we live each moment of our lives, defining everything we've already experienced as the past and what we have yet to face as the future. Therefore, we find ourselves in a thin and complex line between the past and the future, which we call the present. This concept of now becomes the past the instant it is spoken. For example, the moment I say now, that precise instant is already part of my past. Let's reflect on this line that separates the imminent future from the moment it becomes the present. When exactly does this moment, which we define as the present, transform into the past? When does it end and become part of our history? The truth is, we cannot precisely pinpoint this boundary between one moment and the next. Our minds, accustomed to linear storytelling, struggle to grasp the transition from one instant to another. We don't know exactly when a moment ends and another begins. This reflects not only our inability to perceive time concretely but also the intrinsic complexity of its nature. But why can't we see it? Perhaps time doesn't exist at all. It might just be an illusion, or maybe it exists in a completely different form from how we imagine it. Einstein's theory of relativity represents one of the most significant revolutions in our understanding of reality. It teaches us that we live in space-time, a concept that combines the three spatial dimensions with the temporal one. We must, therefore, consider time as a dimension, just like the other three spatial dimensions. We can summarize space with the three dimensions we know: length, depth, and height. These dimensions can be identified with the three Cartesian axes x, y, and z. But to define our position in space-time, we need these three spatial coordinates and one temporal coordinate. Imagine living in an apartment building. To identify your apartment, we first need to determine the floor, for example, the fifth. This would be the z-coordinate. To define our position within the apartment, we need two more coordinates, x and y. So, we have three spatial coordinates, but it is equally essential to define the time. For example, 7 p.m. This is because, at a different time, we were in a different position. Every moment of our lives, every now we experience, marks a unique point in our spacetime. Now, let's talk about the idea of the block universe, one of the most fascinating theories that arises from reflections on the nature of time. We've understood that our position in space-time is defined by these four coordinates. We can associate every moment of our lives with a position, from the day of our birth to today. The block universe theory suggests that the past, present, and future exist simultaneously, as if they were already written, like the pages of a book. Thus, all the space and time in the universe coexist within a block. To better understand how the block universe works, let's consider a concrete example. Right now, am in a certain position. I could decide to take a step forward, but the space behind me will continue to exist, because space is continuous and cannot simply disappear. In fact, I can always go back. I can move in any direction because space exists independently of the position I occupy at any given moment. I am here, and you are there, in front of the computer or perhaps on the couch. Your position is just as real as mine. We are occupying different spaces at this exact moment. Similarly, the same applies to time. It exists both behind and in front of me. My past is just as real as my future. So, my presence at this specific moment does not exclude the possibility that my past and future already exist. Understanding this concept can be disconcerting, as we are used to living in our reality, where the past is everything that has already happened and the future is everything that is yet to come. However, if we start from the idea that, in the block universe, the past and future coexist, then the distinction between past and future loses meaning. It's like opening a book to any page. Are we in the past or the future of the story? It doesn't make sense, right? Now, imagine taking a three-dimensional space and merging it with the three-dimensional space of the next moment, perhaps after 1 second. If we continue to do this with successive three-dimensional spaces, we create a continuous connection from the past to the future. This union forms four-dimensional spacetime. The ball moves in three-dimensional space and changes its position over time. Our ability to interpret reality is limited by the fact that we live moment by moment. We cannot relive the moment we've just experienced nor see what is about to come. In other words, we cannot observe where the ball has been or where it will go. To simplify, we can represent space-time as consisting of two spatial dimensions plus time. On this plane, we have two-dimensional space, and time develops along an axis. The ball, in this case, appears flat and not spherical, as we've eliminated one dimension. For each moment in time, we can find a slice of space, identifying the different positions the ball has assumed. We are merging the space of different moments. Our limited perception forces us to observe only one slice at a time, but if we consider all the positions the ball has taken and look at space-time from this new perspective, we see that time doesn't really flow, it exists in its entirety. The ball exists in space but also in time. Time doesn't flow, so we cannot talk about before or after, about past, present, and future. Space-time remains unchanged because it already exists in its entirety. We've seen that in the block universe, nothing changes, and therefore, the idea of the passage of time loses meaning. To have a more complete view of the block universe, we might represent it as a hypercube, a cube in 4 spatial dimensions. Naturally, we cannot visualize it concretely, as we live in 3 spatial dimensions and the representation would be made on a 2-dimensional screen. You might object that time flows because our clocks measure its passage. Newton argued for the existence of absolute and uniform time, independent of everything else. According to Newton, clocks measured the same time because there was a present that was the same for everyone. People agreed on time because they shared a universal present. However, Einstein came along to disprove the idea of a universal time. In fact, Einstein stated, "For those of us who believe in physics, the distinction between past, present, and future is only an illusion." Einstein's theory of relativity truly refuted Newton's hypothesis of a universal time governed by a common clock. Clocks, for instance, move more slowly where gravity is stronger. Scientific experiments have shown that a clock at sea level moves more slowly than one located in the mountains. So, you age more quickly in the mountains. It is not correct to say that we live in a universal present, as clocks measure different times depending on the conditions they are in. The seconds that pass for us are very different from those passing for someone in a stronger gravitational field. And so, in the end, all we can say is that there exists a different view of the universe, one that transcends our everyday perception. In reality, past, present, and future coexist. In conclusion, we can say that the universe exists in its entirety, and we cannot claim to live only in a real present. So, we hope to have clarified this concept and invite you to reflect on what time really is. It's a concept that deeply concerns us, yet remains mysterious and fascinating in many ways. And what do you think? Do you believe the universe is a block where everything coexists? Or do you think time really flows, making the future something unattainable? You can share your thoughts in the comments below. Thanks for watching.